afternoon, everyone. My name is Danielle Sitalo, and I attend DeBakey High School for Health Professions here in Houston, Texas. For this project, I worked alongside Mihika Dusad from Alexandria, Virginia, and Sashwat Ravishankar from Portland, Oregon, to solve problem B, punishing infants. Our mentor was Seshaiyer from George Mason University, and my team won the Outstanding Award in the SCUDEM competition. So firstly, when we first read problem B, we were instantly captivated. So problem B states that research shows that some infants develop a propensity to react to third-party transgressions by punishing those they perceive as acting out against others. We will refer to this as a propensity for retribution. We are told to assume that the proportion of infants that have this propensity is fixed, and the objective is to study interactions and long-term dynamics of the system as a whole. So our goals in terms of creating a model were to develop a model that includes multiple populations with different characteristics and different propensities of retribution. We wanted to incorporate various behaviors in our model, especially varying degrees of retribution. So how severe the retribution action is, and the alternative actions, such as simply observing a conflict. We seek to study the long-term effects of these interactions in the system, and we generalize our model to real-world scenarios at the end of this project, specifically international conflicts, as we will discuss later on in this presentation. So here are some definitions that we'll be using throughout our model. Firstly, the propensity of retribution, as we stated before, is the likelihood of an observer to punish a third-party aggressor. Furthermore, the propensity to aggress is the likelihood of every party to commit aggressions. And in our model, an individual can take one of three roles at any given moment. Firstly, the observer or bystander role, in which they are just observing a conflict taking place. Secondly, the victim role, in which they are currently being aggressed or attacked. And lastly, the aggressor role, in which they are the ones currently aggressing against the victim. So for this problem, we have also made some assumptions to simplify the model. We assume that the population beliefs and distributions for a group are uniform. We assume that there is always at least one ongoing conflict or instance of aggression. We assumed individuals can only be involved in one conflict at a time, and we determined that actions should be cyclical, meaning individuals can always cease action or move back to a previous course of action taken. Lastly, we assumed linear progression through the states of involvement in conflict. This movement between roles suggests the efficacy of an SIR model, which we will further explain. So for this problem, we utilize the SIR model, or the Susceptible Infectious Recovered model. This is a fundamental mathematical framework used to study the spread of infectious diseases within a population. This was originally developed by Kermack and McKendrick. By analyzing the interactions between these compartments and the rate at which individuals transition between them, the SIR model provides insights into the dynamics of disease transmission, the potential impact of interventions, and the progression of an outbreak over time. In our case, however, the SIR model is used to represent international conflict involving two countries and a bystander. So here's some terminology for our models. Susceptible, or the S compartment, holds countries that are aware of the ongoing conflict. They can then move on into the infected, or the I compartment, which holds countries that are involved in ongoing conflict. Then from here, they can progress into the diplomatic, or the D compartment, which holds countries that choose to pursue a course of action. In stage 2 of our model, this compartment is broken down further. It can be broken down into diplomatic, or D1 compartment, which holds countries that pursue a mild course of action, such as sanctions or treaties, or the D compartment, which holds countries that pursue a harsh course of action, such as war or armed attacks. Finally, from the D compartment, they can move into the recovered, or R compartment, which holds the countries that stop pursuing a specific course of action. So in stage 1 of our model, or the simple model, The S compartment is a population that is susceptible to observing a conflict, while E compartment is a population that is actively observing the conflict but is doing nothing. The D compartment is the population that decides to pursue diplomatic action, like imposing sanctions or sending humanitarian aid. Finally, the R compartment is the population that decides to pursue retributive or unretractable action, getting actively involved in the conflict. Our differential equations are written on the right. In stage 2 of our model, or the complex model, the D compartment is split into 2 compartments. D1 standing for indirect, such as diplomacy or supply donations, while D2 is more direct, such as sanctions or public condemnation. Our differential equations are written on the right. So for stage 1 of our model, we first conducted stability analysis to understand the long-term behavior. Systems such as these often tend towards a final fixed state, in which state must be an equilibrium solution for all rates where exchanges are 0. So the stability analysis is a systematic evaluation of the behavior of a system to determine whether it remains within the desired bounds under various conditions, and is crucial to ensure the reliability and predictability of systems, preventing unexpected or undesirable behaviors. So solving for the equilibrium solution, we obtain this set of equations as seen on the right, in which the equilibrium solution is asymptotically stable as t goes to infinity for all positive values of rates alpha, beta, gamma, sigma, and zeta. Here is an accompanying visualization for the stability analysis. Next, we undertook hyperparameter tuning. Hyperparameter tuning is a technique which uses data to optimize model parameters. Our data was particularly obtained from the Global Sanctions Database, which at the time of the project completion was last updated in the June of 2023. A small portion of the data is shown on the right. With numerically scaled objectives and successes, the centroid lies at 6.793 and 3.040, as seen in the image, which is ultimately indicating that the propensity for the retributive action and the success of outcome, respectively. Finally, once our model was complete, we decided to examine 2 real-world case studies as mentioned before. We let the initial population be n is equal to 300 as a scaling of 3 countries. The first case study we looked at is the Israel and Hamas conflict, in which the US has been pursuing a mild and diplomatic course of action as a third party. We accordingly set alpha, the mild diplomacy parameter, to be weighted higher than zeta, the harsh diplomacy parameter. And in the 2 graphs, these were our findings over a 10-day and 60-day simulation period. In both scenarios, the infected population dies out pretty quickly, depicting the urge of a third party to take some course of action. In the long term, it is clear that the D1 population is greater than D2. So although most countries move into the susceptible department, or they want to remain uninvolved in the conflict, the portion of the countries that continue to employ diplomatic action remains fixed. Overall, in this simulation, our model conveys that if the US continues to employ mild courses of diplomatic action, such as sanctions or treaties, rather than harsh courses of action, the recovered population will continue to grow. In our second case study, we looked at the Russia-Ukraine conflict, in which the US has been pursuing a much more harsh and retributive course of action. In contrast with our previous case study, we accordingly set zeta to be weighted much higher than alpha. And in the 2 images, these are our findings over the 10-day and 60-day simulation period. In the long term, we see that D2 is greater than D1, and the recovered population is smaller than in the first case study. And this finding is supported as more countries have ended their involvement in the Russia and Ukraine conflict. So finally, we were able to create an SIR-based model of the punishing infants problem that is complex and incorporates varying degrees of retributive behavior. By stabilizing and tuning both the D1 and D2 compartments, we were able to analyze the propensity of the third party's courses of action. Some limitations of our model are that we only consider one conflict at a time, and movement between compartments is restricted to linear movements. The likelihood of aggression is also not considered when a conflict begins. Some ideas for future work is that we could try to include additional variables that enable back and forth population movement to a greater extent. We can incorporate more compartments and more rates, as well as considering the environmental factors that could influence conflicts. Fortunately for us, upon receiving the news of our award, we also received constructive feedback for this problem. For instance, one judge pointed out that the rate alpha I that moves countries from compartment I to D in our stage 1 model represents a spontaneous process of change from combatant to diplomatic. But this is not generally what is observed in conflicts. If one seeks diplomatic solution while others do not, both parties remain infected or they remain in a state of war. This is generally, again, not true. Additionally, in stage 2 of our model, the differential equation for I should be negative zeta I and not positive zeta D. Another judge also suggested an idea for a future endeavor as well. We could consider incorporating a sensitivity analysis by running simulations over a range of parameters rather than just a single parameter as we have done, providing a robust understanding of the model's behavior under various conditions. Here are references. Thank you very much.
We still have a few minutes, so if anyone has questions, feel free to ask.
Yeah, I don't have any questions, but thank you very much for the talk. I think the whole process is very good, and the problem with your day is great.
Thank you very much.